Welcome to Geometry Essential Standard 4, Learning Target 10B, where we finished talking about congruent triangles, and then we also tie in talking about CP-CTC, which allows us to prove an extra thing after we know that the triangles are congruent. So first let's decide which method, if any, can be used to prove the two triangles congruent. So here on number 1, we see that they marked we can see that they marked this side congruent to this side, and they gave us this angle congruent to this angle, so we already have a side and an angle. And then we also see that they share this side, so in order that gives us side, angle, side, congruent to side, angle, side. So number 1 is SAS. On number 2, they gave us a side in each one and they gave us an angle, and then they also share this side. Since side angle is not a thing, that in order that goes side angle, we do notice that it's a right triangle, so we have that specialist scenario where it's hypotenuse leg, because this is the hypotenuse of the right triangle and this is a leg, and in the other triangle I know the hypotenuse and the leg as well. For number 3, we see that they give us a side and they give us an angle, and then we look and see if there's anything else we know. We see that we know that this angle here is congruent to this angle here because they're vertical angles. So vertical angles are always congruent. So I have two angles and then a side not between them. So that gives us angle, angle, side. Number 4, you notice that those are arrows and not congruent marks. So the arrows, remember, refer to parallel lines. So if I know that this line here is parallel to this line here, with this being the transversal, I know that this angle is congruent to this angle, and then likewise, because those are corresponding angles. And then likewise, if I have this line is parallel to this line, with this being the transversal, I know that this angle is congruent to this angle. So I have two angles. The one thing that I don't know, though, is any of the side lengths. So these cannot be proven to be congruent. So we'll just write none down for that. And then the last one, we see here on the left triangle, they gave us two sides and the included angle. So for this triangle, we would have SAS. But in this second triangle, they tried to trick us. They gave us two sides and the non-included angle. So this would be SSA. So this is also none, because those two triangles would not be congruent. So given that angle ADB and angle CDB are right angles, so ADB and CDB are right angles, and that angle A is congruent to angle C, angle A is congruent to angle C, prove that the two triangles are congruent. So we would start off by rewriting the given. So angle ADB and angle CDB are right angles. Angle A is congruent to angle C. That's given. Step 2. Anytime there's a vocab word, we need to break down what it means. So given that they're right angles means that they are 90 degrees. So we could actually put that angle ADB is congruent to angle CDB, because we know that all 90-degree angles are congruent. So this is called the right angle congruence theorem. So now I've got everything that we marked in our picture is proven. Now I need to go, okay, I know two angles, so I need to know something about a side. So the only side that I know something about is side BD, is a side in both triangles. So my step 3 is going to say that BD is congruent to BD. And the reason for that, anytime something is congruent to itself, it's reflexive POC. So now that I have two angles and a side in both triangles, now I'm ready to do my proof statement. So I would say triangle ADB is congruent to triangle CDB. And the reason that I know that is by AAS. Remember that when you're doing a proof, your last statement, so statement number 4, will never just be the word prove. I have a lot of students that incorrectly think that prove is never a reason why something happens. So now we move on to the next one. It says, given that C is the midpoint of BD and AE, can we prove that the two triangles are congruent? So they're not asking us to actually write out a proof. They're just asking, can we do it? Well, we need to know what the word midpoint means. So the word midpoint means that it cuts the segment in half. So if it's this midpoint of BD, that means that DC and BC would have to have the same length because C has to be halfway between them. And likewise, if it's the midpoint of AE, that means that AC and EC would have to be congruent. So now I have two sides in both triangles. Now I need to look, is there any other can I prove the third sides, or can I prove one of the angles congruent? And what I see here is that this angle would be congruent to this angle because of vertical angles. So now I have SAS in both triangles. So the answer is yes, and the reason for it would be SAS. So now we give you a proof where we're just asking you to fill out the reasons. So C is the midpoint of BD. That's simply given. They gave it to us in the statement above where they said C is the midpoint of BD. And then they say AB is perpendicular to BD and BD is perpendicular to DE. And those are also given. Remember, the upside down T stands for perpendicular. Next, they say BC is congruent to CD. Well, why do I know that BC is congruent to CD? It's because of the statement 1. So BC is congruent to CD is because C is the midpoint of BD. So this is definition of midpoint. So remember, whenever there's a vocab word in a given, usually your next step is going to be to use the definition of that vocab word. Okay, next, whoops, don't want to scroll down too far. Next, angle BCA is congruent to angle ECD. So the reason why we would know that those two angles are congruent is by vertical angles. Next, angle ABC and angle EDC are right angles. Well, remember, we have not used step 2 yet, where it said AB is perpendicular to BD, meaning that that's a right angle, and that BD is perpendicular to DE, means that that is a right angle. So this is definition of perpendicular. So definition of perpendicular says if they're perpendicular, they make right angles. So now, since I know that they're both right angles, I could say that they're congruent to each other. So this would be that same thing that we just used. So the right angle congruence theorem says that all right angles are congruent to each other because they're all 90 degrees. So now if we look back at our picture, I have in this triangle, I know two angles and I know the side between them. And I have the same thing in this triangle, that I have two angles congruent and the side between them. So the reason why I would know that the two triangles are congruent is by ASA. Now we're going to get on to a point where we can take the proof a step further, or even two steps further if we need to, and prove things that we might actually need to know. So if we know that the triangles are congruent to each other, like on our last proof we proved that the triangles were congruent, then I know that the things that I didn't already know were congruent are congruent after that. So we use CP/CTC for that, and I know that can be kind of difficult to remember, but it's not bad once you say it a few times. CP/CTC simply stands for corresponding parts of congruent triangles are congruent. So once we know that the triangles are congruent, we know all of the corresponding parts of those two triangles are also congruent. So for this example, we can see here that we've already proven that with these two sides equal, and these two sides equal, and these angles congruent by vertical angles, we can see that these triangles are congruent by SAS. Before we used SAS, did we know anything about side length AB and side length DE? No, we didn't. That they didn't tell us anything about it. But now that we know that the triangles are congruent, so I know they're the same size, they're just in different places, I now know that AB is congruent to DE, and my reason for that would be CP/CTC. So it's just a way, once we've proven that the triangles are congruent, we now can say something about the parts that I didn't know anything about. So now they want us to prove that angle S is congruent to angle U. So I look at the triangle and I already know that SV is congruent to TU. And I also know that ST is congruent to VU. And I know both of those because it was given in the picture. They had already marked it for me. Now I look and go, okay, is there anything else I know has to be true? Well, they share this side TV. So step 2, I would say TV is congruent to TV. And the reason for that, anytime something is congruent to itself, you think about your reflection in the mirror, that is reflexive POC. So now I have all three sides congruent to each other. So my step 3, I can say that the two triangles are congruent. Remember, the order matters here. So I'm going to go STV, so triangle STV is congruent to, well, angle S is the same as angle U, so this is going to go triangle U. And then ST, the first two letters, is congruent to UV, so it has to go UVT. And my reason that I can say that the triangles are congruent is by SSS, that I know all three sides in both triangles. So now I go back and I go, okay, well, what am I trying to prove? I'm trying to prove that angle S is congruent to angle U. So my reason for that is CP/CTC. we can never use CP/CTC before I've proven the triangle is congruent. So I had to have that the triangles were congruent before I could ever use a statement of CP/CTC. So now this one is a lot the same. Why don't you pause the video and see if you can complete this on your own. Okay, welcome back. So what you should have started out, first step is always going to be given. So what did they give us in the triangle? Well, they told us that NM was congruent to PQ. And they also told us that angle N was congruent to angle P. So they gave us 2 bits of information. I look at the picture and they show us vertical angles here. Now remember, I can't name that angle L because there's 4 angles pictured there. So when I name those 2 angles, that would be angle NLM is congruent to angle PLQ. And my reason for that is vertical angles. So now I have 2 angles in both triangles and the non-included side, so I can prove the triangle is congruent. So triangle NLM is congruent to, well, congruent angle N was the same as angle P, so the P has to go in the same spot as the N, and then NL is going to be the same as PL, so it has to go PLQ. And my reason for that is AAS, because I knew 2 angles and the non-included side. So now that I have the triangles congruent, I look back up here and go, okay, I needed to prove that LQ was congruent to LM. So LQ, I now know is congruent to LM. And my reason for that is CP/CTC. And you notice LQ was the last 2 letters of this triangle. LM is also the last 2 letters of that triangle. So thinking back to one of our first lesson over congruence, how the order of the letters matters. So now we come up to this new problem, and when we look at that, we see that they give us 2 angles are congruent here in angle 1 and angle 2, and then they also say angle 3 and angle 4 are congruent. And they want us to prove that triangle DCE and BCE are congruent, which doesn't look too bad in itself, but this one can actually be kind of tough. So what our plan is, because they just want us to come up with a plan, so our plan is to show that this big triangle CAD and CAB are the same. So in order to do that, I already have 2 angles, so I'd have to show that AC is congruent to AC by reflexive, POC. So now I would have angle side angle for triangle CDA and triangle CBA. So now that I know that those triangles are congruent, what I know when I'm trying to talk about triangle BCE and DCE is that CD is the first 2 letters and BC is the first 2 letters. So I know that BC is congruent to DC by CP/CTC, which helps me because when I'm looking at triangle CDE, that's the side of a triangle, and same thing with CBE, that's the side of the triangle. So now I have a side and an angle, and when I look at that, I also have side CE is a shared side in both triangles. So that would be by reflexive POC. So now I'd have the two triangles congruent. BCE is congruent to triangle DCE, and that would be by SAS, because I knew two sides and the angle in between those sides in both triangles. Please go sign up for your Teacher Talk and continue to work on the online practice. Thank you.